All right. What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today is the day. We are live right before an SAT. That is tomorrow, June 3rd. And I'm here today to help you guys prepare one last time with some essential formulas. So this is a video that is out there actually. But I want to go through and talk through these 23 essential formulas. I think this is probably the most impactful information and material that you can get, and make sure that it's clear and fresh right before test day. So we're going to go through the 23 formulas. Then I'm going to leave some time for a little Q&A. And that's it. I'll send you on your way. Obviously, there's tons of other videos on the channel, whether you're taking the digital or the kind of like standard form of the SAT on paper if you're in the US. There's content for all of it. And again, remember, from a topic standpoint, it's still pretty much essentially the same. It's, you know, maybe stylistically there's some nuances, but at the end of the day, from what subject matters are contained on the math portions of the SAT, there's really no difference. So you want to, can still use all of those same videos for both tests. From a subject matter standpoint, it just might be, hey, the format is different, etc. Anyways, without further ado, let's do this. Hey, what's up, Jerry? So Yazan, this is like a subject matter review, which means this is going to be good for the digital or the domestic version when you're taking it on paper. So it's good for both. Okay, here we go. So formula number one that we're going to talk about is slope of a line. That's, again, for linear equation. And to calculate the slope, if you have two coordinates, it's going to be the difference of the y values over the difference of the x values. Okay. So for example, if we have this equation, if you have these coordinates here, 7, 2, 5, 1, it's going to be the difference of the y values, meaning 2 minus 1, right, over the difference of the x values, 7 minus 5. Now, again, I could go in the other order. It doesn't matter, but you have to choose one coordinate, whether it's red or blue, to always be first. And then you'll get the same result either way. So you get 2 minus 1 over 7 minus 5, which is 1 over 2 for the final slope. Done. Okay, next we come to slope-intercept form of a line. So this is a very special format for a linear equation. The reason why is because you can see the slope and the y-intercept from this form. So for example, it is y equals mx plus b. And again, here m is your slope and b is your y-intercept. It's great to get it into this format if it's not already in the format, if they're asking for, hey, what's the slope, what's the y-intercept? So you can kind of format it and be like, oh, boom, there it is. Like here, my slope is 2 and my y-intercept is right there, is 7. Okay, there's the representation of the slope, up 2 over 1, right? And don't forget, any whole number slope, it's really that number over 1. A rise, in this case, of 2, a run of 1. All right. Okay. Now we have point slope form, and this is a great format if you're given a point and a slope to come up with the equation of the line. So here, again, m is your slope, and those two x1 and y1 values are values of an actual coordinate. So in this case, the coordinate on the line would be 3 and 4, and the slope is 3 over 2. So we could see this on a graph here. Again, here's the point 3, 4, and to go to another point on the line, we have a rise of 3 and a run of 2. Okay, right 2, up 3. Or it can also be flipped, down 3, left 2. They're both positive, both negative. It ends up being the same. All right. Next, we have the midpoint formula, which will find literally the middle point between any 2 points. So what you're doing really is you're taking the average of the x values, you're taking the average of the y values. So that's pretty logical, right, to get the midpoint, middle point. So if we have an example here, 8, 4, 6, 7. To get the midpoint, you're taking the average of 8 and 6, literally adding 8 and 6, dividing by 2, and then taking the average of 4 and 7, dividing by 2. This would be 7, 5.5. Okay. Next is the distance formula. This is probably, I'd say, most commonly used when you're trying to find the radius of a circle. They'll give you the center and then an outer point, so you can use that to calculate the radius. But anyways, what you're doing is you're taking the difference of the x values squared, the difference of the y values squared, adding them, and then square rooting it. So here we have two values. It would look like this if you plugged it in, right? 5 minus 1, the x values. 3 minus 0, the y values. So that would be 16 plus 9, which is square root of 25. And the square root of 25 in this case would be a distance of 5. So that's how you apply it. Some Prasanna asks, what's midpoint value useful for? I mean, sometimes literally you'll be asked to find the midpoint of two lines, of two points explicitly in one of the questions. They might, I've seen it too before, where you might have let me see if I can draw it actually. Give me 1 second. I'm going to have to add this thing. There we go. 1 second. Okay, let's see if this works. Okay. You might have a circle here, and they give you, I'm just kind of making this up, but let's say they give you a point of 3, 7, and over here, let's say 11, 7. Okay, you might need to find this point that's right in between. Now again, it won't tell you the vertical distance or the y value, but this middle distance here is going to be at the average of 3 and 11. That's finding the middle or the midpoint between those two, right? So 3 plus 11 divided by 2 for this midpoint, and that would give you 14 divided by 2, which is at 7. So that you know that this middle point of the circle would be at 7, something. That's a potential instance where the midpoint formula might be useful. Okay. Okay. Next we have, somebody mentioned you can use it to find the vertex too. That's true, right in between the x-intercepts as well. Okay, this is length of an arc of a circle, and you get this by doing the central angle n divided by 360 times 2 pi r. By the way, 2 pi r should look familiar. That is circumference of a circle. That's actually provided on the SAT in the formula sheet. So literally what you're doing is you're taking a piece of the circumference, and that might help you remember it. So for example, here would be the diagram. There's the arc length. It's like that little crust of the pizza, that central angle n over 360, and so on. Oops, sorry. And that's that. Now we get to area of a sector. Again, it's a piece of the circle again, but it's area. It's like a full piece of pizza, as opposed to just the crust. And it's a similar kind of thing, right? You're taking pi r squared, the area of the circle, and then taking that same fraction, central angle n over 360 times the area. That gives you the sector. And there it is, pizza slice. Okay. Quadratic formula. So you might remember this formula, right? Got to know it. Very important. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And it can be pulled from this formula. Being in standard form, sorry. So if something's in standard form, if a quadratic's in standard form, you try to find the x-intercepts. Boom. Plug it in like this, right? And that's it. So have that memorized, and that can be a backup if a quadratic is not factorable and you need that 0. SOHCAHTOA, little trigonometry, okay? And stands for sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Now, again, remember, this is relative to which angle you're choosing, right? But these are all for sine. And so that's why it's color-coded. The opposite of A is blue, the adjacent of A is brown, and the hypotenuse, well, that's always going to be just what's opposite to 90, that's green. Probability, very straightforward. It's just wants you to remember that it is the number of favorable outcomes to the number of total outcomes. For example, if you're, let's say, rolling the dice, and the way that you can win is by getting a 1 or a 2, okay? You have 2 ways to win out of a total number of 6 outcomes. 1, 2, 3, 4, 5, 6. So your probability of winning would be 2 out of 6 or 1/3. Just an example. But that's how you put together a probability. Give me 1 second, guys. Somebody's at my door. Hold on 1 second. 1 second. Hey, what up? Sorry. You have to open the HVAC gate? Yeah, give me 1 second. Whoops. All right, guys, 1 second. I just have to open my gate. Give me 1 second. I'll be my fence thing. I'll be right back. All right, guys. Sorry about that. Okay. Let's pick right back up here. All right. Here we go. We're going to go to the next one, which is the circle equation. This is the equation of a circle on a coordinate plane. All right. And this one you got to know. It's almost invariably going to show up in some format. But here it is. It's x minus h squared plus y minus k squared equals r squared, where the center of the circle is h comma k, right? And you'll notice that it's positive h, positive k. So if it's minus 4, minus 7, right, it's going to be positive 4, positive 7. And then the radius is going to be the square root of whatever's on that side, right, because that's radius squared. So if we look at an equation here, just as an example, the center would be positive 2, negative 5, right, because you flip the value. And the radius is the square root of 36, which is 6. Okay, so there's your circle equation. Next, we have exponential growth. Here, A is your initial value, okay, and R is the growth rate in decimal form. So if it's like growing at 10%, it'd be 0.1. If it's growing at 150%, it's 1.5, and then T is your time. Okay. So as an example, exponential growth, we'd have an initial value of 200. We'd have a growth rate of 13%, and the time would be 3 years. This is how you'd plug it in. You'd have 200 as that A value, 1 plus 0.13, and then to the third power. Likewise for exponential decay, this is when it's diminishing, all right? It's a similar idea if we have initial value of 150, decay rate of 9%, and time of 2 years. Now, instead of adding 9% or 0.09, we'd be subtracting it and then square that, multiply by 150. So that's the idea. Oh, yeah. So you're saying a 90% increase. So you said which formula? So it's the same formula, right? It's just, that's what I'm trying to show you here is it's just plus or minus. So if they'd say, 10% decreasing, then it's minus 0.1, which gives you 0.9. If it's a 10% increase, then it's plus 0.1, and then it ends up being 1.1. Okay? Next, we got vertex of a parabola. So this is very important if you're trying to find the vertex. What do? Well, going from standard form, you use this formula called negative b over 2a, and that gives you the x value of the vertex of any parabola. Then to find the corresponding y value, you take this value and you plug it in. You can solve for it, but this is the important part, negative b over 2a. Next, we have vertex form of a parabola, okay? So if you have a parabola, again, their standard form, vertex form would be a times x minus h squared plus k, where h comma k is the vertex, okay? H comma k would be the vertex. That a value is important too. That would dictate if it's positive, it goes up, opens up. If it's negative, it opens down. And then it kind of determines how wide the parabola is. If it's 10, it's going to be like more stretched vertically, more narrow. If it's like 1/2, it's going to be wider. Okay. All right, 15, Pythagorean theorem. This is one that's actually provided in the formula reference sheet on the SAT. But here's what it is. Most famous formula, or one of the most in math, a squared plus b squared equals c squared. And this is for any right triangle. You can find the third side if you know two of them. And here would be an example, right? Here's A, B, and C. A and B, it doesn't matter which is which. A doesn't have to be the smaller leg or the bigger leg. A and B just have to be legs. Typically, it's assigned to the smaller leg. That's just how it goes, but it can be anything as long as C is the hypotenuse. So that's it. Okay, distance equals rate times time. This seems like a pretty straightforward formula, and some people might be like, whatever. It doesn't add that much, but I do think it's actually pretty valuable for some complex word problems, just to remember this as scaffolding, as something to lean on in terms of, hey, this is the prototype. We're talking about rates and distances. I'm going to lean on this formula and plug things in here. I do find it to be helpful, and that's it. Distance equals rate times time. Okay, then we've got this little formula here. Sine of x equals cosine of the complement of that angle. This is always going to be true, number one, but number two, the College Board loves to test this concept in particular. In fact, there was a question on this exact topic that I did yesterday in the May 2023 SAT walkthrough, if you haven't seen that yet. So what this means is that sine of 10 equals cosine of 80. Why? Because 10 and 80 are complements. All right, and so on and so forth. We can come up with examples all day, right? As long as the angles are complementary, sine of it equals cosine of the complement, and that's that. All right, next we have sum of solutions of a quadratic. I didn't see this actually on the last SAT, but they do like to ask about this. So they'll give you a quadratic and they'll say, hey, what is the sum of the solutions? You can, of course, get the two solutions using the quadratic formula, factoring, whatever, and then adding them together. But a simpler way to do this is this little formula. It is, if it's in standard form, negative b over a. It's amazing. So you can save yourself a couple minutes if you remember this. So not negative b over 2a like a vertex, but negative b over a. And for example, here's if I said, hey, what's the sum of the solutions for this equation? It's negative 7 over 2. And that's it. There's your answer. You don't even have to use the quadratic or anything. Next, we come to the discriminant. The discriminant is b squared minus 4ac. You might recognize it from being in the quadratic formula under the radical. Okay. And this tells you the nature of the solutions of any quadratic equation. So, for example, if it is in fact negative, right? Here it'd be, what would it be? Negative 31, okay? Then you'd say, oh, well, there are no solutions, okay? If this was a quadratic equation with y instead of 0, then we'd say, oh, there's no x-intercepts. Same thing, okay? When set to 0, no solution. Set to y, no x-intercepts. Here's an example. B squared minus 4ac is 0, right? 16 minus 16. And that means there is one real solution. That makes sense because if the radical in the quadratic formula is 0, there's no plus or minus. That's what makes the two solutions, hence one solution. Last but not least, we have where it is greater than 0, right? Here we have 36 minus, what is that? Or plus 84, 120, right? So 120 is greater than 0. In this case, you'd have two real solutions, and this is it. You can't have any other result with parabolas. No real solution, one real solution, two real solutions. Okay? The goat hat was better. Somebody said, yeah, that hat's awesome. I love that hat. One of my students got that for me. Shout out to my students who bought me the goat hat. Okay, area of an equilateral triangle. This one is not as essential, but it's nice if they do ask about it. It's a nice little shortcut. If you forget it, you can cut this into a special right triangle. You just drop an altitude, make it into a 30, 60, 90, figure out the height, boom, boom, boom. But as a little shortcut, if they're like, hey, what's the area of this nice little equilateral triangle? It's the side length squared times the square root of 3 over 4 for any triangle. For example, this one, it'd be 1 squared times square root of 3 over 4. This one would be 2 squared, which is 4 times square root of 3 over 4. That would, of course, reduce to just square root of 3. And 3, just showing you one more example, 9 times the square root of 3 over 4. That's it, equilateral triangle. 21, Pythagorean triples. Again, not essential that these are memorized, but very helpful because they always show up on this thing, on this SAT, right? That means if you have a right triangle, a 3 and a 4 for the legs, the hypotenuse is a 5, 3, 4, 5, right? And you have different versions of that, but we'll get to that in a second. Another good one to know, 5, 12, 13, 7, 24, 25, and 8, 15, 17. Now, there's lots and lots of other ones. I think theoretically there's infinite. But these are the 4 that they usually like to test on. And don't forget, this comes with their multiples. So you also have a 6, 8, 10, 9, 12, 15, et cetera, 15, 20, 25. So look out for those as well. 5, 12, 13. Here's some multiples. The bigger multiples of those other ones are not as common. I'd say 16, 30, 34 I've seen. Definitely 10, 24, 26. But the 3, 4, 5 iterations, most common. All right, 22, perpendicular slope. If you have a slope of A over B, the perpendicular slope is the opposite reciprocal, aka negative B over A. If you're talking parallel lines, A over B, it would be A over B. The slopes are the exact same, just FYI. In this case, this line would have a slope of 2/3. The perpendicular line would have a slope of negative 3 over 2. Boom, done. That's it. And finally, sum of angles of any polygon. Not as common, but we threw it in there just in case you need it. And the sum of the angles of any polygon are, if you have n sides, right? It's n minus 2, the number of sides minus 2 times 180 to get the total amount of angles. So for example, n is the number of sides, by the way. For example, what do the angles add up to in a triangle? We know it's 180, but we can prove it with this formula, or show it again with this formula. It's n minus 2, so 3 minus 2 times 180. That's 1 times 180 is 180. Boom. What about for a quadrilateral? Now it's 4 sides. 4 minus 2 times 180, which is 360. That's what all the angles add up to in a quadrilateral. Last but not least, a pentagon. 5 minus 2 times 180. That's 3 times 180. Boom, is 540. That's it. Okay, guys, this is what I wanted to review with you today, these formulas. Let's see. Oh, awesome. You saw that we were live on Discord. Same can be applied to tangent slopes. Yeah, for sure. Tangent slopes, if you're talking about a line that's tangent to a circle touching the radius, boom, they are perpendicular. And, okay. Let's see, any other questions? So I gave you guys 23, but then there's an additional like 10 or something on the reference sheet if that's what you're asking about. Let's see. How to get H? What do you mean from the standard form? Are you talking about for a parabola? I don't have any predictions per se in particular about what could be on the SAT. Let's see. Like to know about prisms. Yeah, so the thing is, for a prism, you're given the volume formula on the reference sheet. And, I'll tell you like this, okay? Here, wait, let me back this up a little bit. If you have a triangular prism, for example, if you are asked to find the surface area, the main thing to remember is just, look at all the surfaces. Literally, you have a rectangle here. You'd have a rectangle on the bottom. You have a rectangle in the back, right? And then you have 2 triangles. So you calculate the area of those two triangles. Think of it, so just break it up into pieces. If we're talking about the volume of any prism, but again, this is given on the reference sheet. Let's talk about a rectangular prism. This one's a little easier, but hold on, let's draw it out like this. You take the area of the base. Let's say in this case, it would be this rectangle. And then you multiply it by the height. That's it. Same with a triangular prism, okay? With a triangular prism, you take the area of the triangle, and then you multiply it by the height of this. Same thing, right? So that's it. Yeah, they will take your phone usually. It always depends somewhat from test center to test center. But yeah, they'll take your phone. Almost certainly. Yeah, you're supposed to, oh, you know what? For the digital SAT, I'm not sure if you need to print your ticket. I know for the regular one, definitely. All right, guys. I think we're about to wrap up. Somebody said long division and synthetic division. Yeah, so that's in my critical concept videos. I do talk about both of those. I think they're not as common, like as huge of concepts, but there are cases where long division is gonna be useful in terms of like, hey, what's this polynomial over this polynomial is equivalent to what? And then what they did is they carried out the long division, put the remainder there. So for those particular questions, I'd say it's useful. Synthetic, I do teach it in my critical concept videos just in case, but it doesn't come up that often, to be honest. Okay, guys, that's it. We're going to wrap for this morning. Thank you guys so much for joining. I hope it was helpful. I hope it was useful. Go knock this out, and then you can enjoy your summers. I wish you all the best of luck. Leave me comments or questions if you have any, if you're not watching this live or whatnot. And that's it, ladies and gentlemen. You got this. You can do this. Thank you guys so much for joining, and I will see you in the next